First of all, thanks for your flexibility for allowing me to do this class remotely and asynchronously. So what we're going to do today is to talk about how we draw the Lewis structure of simple covalent compounds. So this is a way for us to represent the structure of a covalent compound, which shows how the atoms are bonded to one another. So to start with, we need to understand what we mean by a covalent bond. So we've been talking about ionically bonded compounds where one atom takes the electron from the other atom, so one atom becomes negative and the other atom becomes positive. And those positive and negative ions are attracted to one another and form an ionic bond. In a covalent bond, what happens is that unpaired electrons in one atom pair up with unpaired electrons in another atom, so that we form a pair of electrons that's shared between the two atoms. And the way that we represent shared electrons is by drawing a line between the two atoms. So this line between the two atoms indicates two electrons that are shared between the two atoms. So the first thing we're going to need to do in order to be able to draw Lewis structures is to figure out how many unpaired electrons atoms have that they have available for sharing. And so when we're talking about covalent bonds, we are only talking about the valence electrons, the electrons in the outermost shell of each atom. The core electrons do not participate in bonding, and only the valence electrons will be considered. So remember that if we look at each group, each column in the periodic table, that tells us how many valence electrons a given atom has. So group 1 has 1 valence electron, group 2 has 2 valence electrons. When we get over to group 13, that has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8 valence electrons. So the key to thinking about how many unpaired electrons an atom has is to recognize that in the valence shell, the electrons are going to be unpaired first, and then we're only going to start pairing electrons when we have to. So if we think about hydrogen only has 1 electron, and so I'm going to represent that electron by a dot. Little dot means an electron near the atom. And that 1 valence electron doesn't have any electron to pair with, and so there's 1 unpaired electron. If I have 1 unpaired electron, I can make 1 bond. Let's do carbon, and then I'm going to let you do the other ones on your own. So carbon has 4 valence electrons. It's in group 14. And so if I think about where those electrons go, they're going to go in that second shell, which can hold 8 electrons, 8 valence electrons, and they're going to be unpaired before I start to pair them. And so each of those 4 electrons can be unpaired in carbon, and so carbon can make 4 bonds. So at this point, pause the video and work out the number of valence electrons, unpaired electrons, and number of bonds for nitrogen, oxygen, and fluorine. And after you've done that, you can start the video up again, and we'll go through what those should be. Okay, so if we think about nitrogen should have 5 valence electrons. It's in group 15. So 1, 2, 3, 4, 5, which means that it has 3 unpaired electrons and can make 3 bonds. If we move on to oxygen oxygen is in group 16, so it has 1, 2, 3, 4, 5, 6 valence electrons. 2 of those are unpaired, so 6 valence electrons, 2 unpaired, it can make 2 bonds. And then if we think about fluorine, fluorine's in group 18, so it has 17, so it has 7 valence electrons. And so 1, 2, 3, 4, 5, 6, 7, not 8. So there's 1 unpaired electron, and it can make 1 bond. Okay, so there are about 4 or 5 steps that we need to go through to draw a Lewis structure. And so we're going to use CO2 as our test molecule for practicing this, or showing you how that each of the steps works. And we're going to go through this CO2 molecule step by step, and then I'm going to give you some ones to practice on. Okay, so the very first step is that we need to count how many valence electrons we should have in this structure. So we need to figure out how many valence electrons does carbon have, and remember that carbon has 4 valence electrons. And how many does each oxygen bring? Remember that oxygen is in group 16, so each oxygen has 6 valence electrons, and there are 2 of those, so we have a total of 12 valence electrons from the oxygens. There are no charges. This is a neutral molecule, right? So there's no charges. If I had a negative charge, I would need an extra electron because I'd have to account for that negative charge. Each negative charge brings in 1 more electron. If I have a positive charge, that means that I've lost some electrons, so I have to subtract the number of electrons for each positive charge. So since I don't have any charges, I don't have to worry about that. So my total is 4 electrons plus 12 electrons, and so overall I should have 16 electrons in my structure when I'm done. Okay, the next step in drawing a Lewis structure is to figure out which atom is the central atom. The atom that can make the most number of bonds is the one that's going to be the central atom because it can do the most sharing. So it'll be in the middle where it can share with most of the atoms. So remember that carbon can make 4 bonds and oxygen can make 2, which means that we're going to put carbon in the center. Okay, so that once we figured out which is in the center, we're going to draw what we call our skeletal structure. And so all you're going to do is put the central atom in the center and connect each of the other atoms to that with a line. Remember that this line represents 2 electrons. It's a bond made by 2 electrons that are shared between the oxygen and the carbon. Okay, so once we have our skeletal structure, so remember our skeletal structure looked like this, the next thing we're going to do is figure out how many more electrons I need to put into the structure. So remember I had 16 electrons total, and I've accounted for 2 electrons by this bond and 2 electrons by this bond. And so I've accounted for 4 of the electrons. So that means I have 16 minus 4 is 12 electrons left to put into my structure. So what I'm going to do is I'm going to start putting those electrons in pairs around this outside atoms. So 2, 4, 6, 8, 10, 12. Now I have the correct number of electrons in my structure, so I can't put any more electrons in and I can't take any electrons out. I have to have all of those electrons represented in my final structure. Okay, so let's redraw where we were. We have carbon connected to each of the oxygens, and we have 3 pairs of electrons around each of the oxygens. So the next thing that's important is to make sure that each of the atoms has a full valence shell. In other words, each of the atoms in my structure has 8 electrons around it. So if I'm counting electrons around just this oxygen, I have 2, 4, 6. This bond is 2, so that's 8. 2, 4, 6, 8 around that oxygen. Then if I look at this oxygen, I have the same thing, 2, 4, 6, 8. But if I look at this carbon, I only have 2, 4. So the carbon does not have a full valence shell, which means that I need to do something to give it some more electrons. It needs actually 4 extra electrons. Remember, I can't put any new electrons in, and I can't take any electrons out of my structure, so I just have to move electrons around. And what I'm going to do is I am going to move these 2 electrons, I am going to move these, let's draw our electrons back in because I erased them. So I'm going to move these 2 electrons in here, and I'm going to move these 2 electrons in here. So I move lone pairs, these pairs of electrons that are around the outside atoms are called lone pairs. I move lone pairs of electrons in to make bonds with the central atom. So if I redraw this, now I have what I had before, but now this oxygen only has 2 lone pairs because I've taken 2 of those electrons and moved them in to make another bond with the carbon on both sides. And so now if I count my number of electrons around each atom, I find that I have around this oxygen 2, 4, 6, 8, and around this oxygen 2, 4, 6, 8, and now around my carbon I have 2, 4, 6, 8. So every atom in my structure has 8 electrons. So in summary, you want to go through each of these steps when you try to draw a Lewis structure. So first, the very first step is to count all the valence electrons. Make sure you're adding electrons for anions and removing electrons for cations. Draw the skeletal structure. Remember that just includes single bonds. Figure out which atom's in the center, draw a bond to each of the other atoms to that central atom, and then distribute the remaining electrons on the outside atoms, but in pairs. They have to be in pairs. And then check for octets and make multiple bonds only if it's necessary to give the central atom enough electrons to be 8 around each atom. The job is for you to practice. So when I brought these slides in, the superscripts and subscripts didn't actually show up correctly, so let me just rewrite these for you. Make sure that you understand what I'm talking about. Carbonate, CH4, that's methane, C, Cl2, F2, O2, and N2. Okay, so the last thing to do for this class is to practice drawing these Lewis structures. So pause the video, get your answers, and once you have your answers, go ahead and start the video again and we'll draw the actual structures. Okay, so let's do number of valence electrons for each of the structures first. So nitrogen is in group 15, so it has 5 valence electrons. Each hydrogen has 1, so 5 plus 3 is 8 for ammonia. Ammonium has 1 more than that, 5 for the nitrogens, and then plus 4, 1 for each hydrogen, so that's 9. But it has a plus charge, so I have to remove 1, so it still has 8. Nitrate has 5 from the nitrogen and 6 from each of the oxygens. So 6 times 3 is 18, plus 5 is 23, but I have to add 1 for the minus charge, so that's 24 electrons. Water has 6 for the oxygen and 1 for each of the hydrogens, so 6 plus 2 is 8. CO has 4 for the carbon and 6 for the oxygen, so that's a total of 10. And then carbonate has 4 for the carbon, 3 times 6 for each of the oxygens. 6 times 3 is 18, plus 4 is 22, but it also has a 2 minus charge, so 22 plus 2 is 24. And then CH4 has 4 valence electrons for the carbon, 1 for each of the hydrogens, so 4 plus 4 is 8. And then CCl2F2, chlorine and fluorine are both in group 17, so they both have 7 valence electrons. 7 times 4, 2 for the chlorine and 2 for the fluorine, is 28. And then the carbon has 4 valence electrons, so 28 plus 4 is 32 electrons. O2, oxygen is in group 16, so that's 6 valence electrons from each oxygen. 2 times 6 is 12. And then for nitrogen, each nitrogen has 5, and 5 times 2 is 10. So 10 valence electrons for the nitrogen. Okay, for the central atom in ammonia, hydrogen can only ever make 1 bond, so it can't be the central atom. So nitrogen has to be the central atom. Same for ammonium. If we look at nitrate, NO3 minus, nitrogen can make 3 bonds, oxygen can only make 2, and so nitrogen makes the most, so it's the central atom. Again, hydrogen can never be a central atom, so oxygen is our central atom. Now, when I only have 2 atoms, there's not really a central atom. They're just bonded to each other, so I'm going to say not applicable here. When I look at carbonate, CO3, carbon can make 4 bonds, oxygen can only make 2, so carbon is in the center. Same thing with CH4, hydrogen is never a central atom, so carbon has to be the central atom. Group 17 atoms can only make 1 bond, carbon can make 4, so carbon's in the middle. And then O2 and N2 only have 2 atoms, so again, there's not really a central atom, we'll just say not applicable. So if I'm going to draw my skeletal structure for ammonia, I'm going to put nitrogen in the middle, and I'm going to put my hydrogens with single bonds to my nitrogen. For the NH4, I have 4 hydrogens attached. For NO3 minus, I'm going to attach my oxygens to my central atom. For water, oxygen's in the middle, hydrogens are off to the side. Okay, so just 2 atoms connected together. Carbon's in the middle, oxygens are around the carbon. Carbon's in the middle, I've got 4 hydrogens around my carbon. And then CCl2F2, I've got 2 chlorines attached and 2 fluorines attached. Oxygen, 2 atoms, nitrogen, 2 sorry, I have to make that a nitrogen. 2 atoms just attached to each other. Okay, so for my final structure, remember that there's a couple of steps here. I need to put the rest of the electrons around the atoms, right? And the outside atoms in pairs, if I can. So let's count up how many electrons we've already used. So 2, 4, 6, I had 8, so I need 2 more to put in, right? So I have to put 2 more in. I cannot put any more electrons on hydrogen. So here's the thing. When I have hydrogen as my outside atoms, hydrogen only has 1 valence electron, and it can't take any more than 2 electrons because those electrons are in the n equals 1 shell, which can only take 2 electrons. So hydrogen never has 8. Hydrogen only gets 2 electrons. So since I can't put those extra 2 electrons on the hydrogens, I'm going to have to put them on the nitrogen. So I'm going to put those on the nitrogen, and then my hydrogens are attached to my nitrogen. So if I look at this, then my nitrogen has 2, 4, 6, 8, and each hydrogen has 2 electrons, so everything is full valence shell, and we're all good to go. So if I look at ammonium, I've used 2, 4, 6, 8 electrons. So I've used all my electrons. I can't put any more electrons in. And you'll notice that the nitrogen already has 2, 4, 6, 8 around it. And each hydrogen has 2. So that is my final structure for ammonium. So I'm all done. I don't have to do any futzing around. All right, so for the nitrate, I have 2, 4, 6 that I've used. 24 minus 6 gives me 18 more electrons that I need to put on. So let's start putting those in pairs around the outside atoms. Their outside atoms are oxygens, so I'm okay to put pairs of electrons around those oxygens. 2, 4, 6, 8, 10, 12, 14, 16, 18. Now I have all of the electrons that I need in my structure, but if I look at my nitrogen, I only have 6 electrons around my nitrogen, so I'm going to want to take a pair of electrons and make a double bond so that my nitrogen has a full 8 electrons around it. So if I redraw that guy, I'm going to end up with a double bond to one of the oxygens, and I've used up a lone pair, so that oxygen only has 2 lone pairs, and then each of the other oxygens has 3 lone pairs. And that would be my final structure for the nitrate. Okay, so for water, we've got 8 total electrons. I've used 4, so I have 4 more to put in. I can't put them on the hydrogens, so I'm going to have to put those on the oxygen. And when I do that, I end up with 8 electrons around the oxygen, 2 around each hydrogen, so everything has a full valence shell, and I'm good to go. All right, so for CO, we've got 2 electrons that we've already put in. We need 10 total, so we need to put 8 more on there. So let's start by putting them on the oxygen. 2, 4, 6, 8. Okay, so that looks kind of weird. Let's see what we can do here. So we have right now, this carbon only has 4 electrons. The oxygen has 8, but the carbon only has 4. So we're going to need to start making some double bonds to try to get things to the point where we have 8 electrons around everything. So I can bring 2 electrons in here. That'll give the carbon 6. It still needs 2 more, so let's bring another 2 electrons in here. And if I redraw that, I end up with a triple bond and a lone pair on the oxygen and a lone pair on the carbon. When I do that, both atoms get 8 electrons around them, and that is the best structure for carbon monoxide. All right, so moving on to carbonate. Right now I have 2, 4, 6 electrons. I need 24 total. So 24 minus 6 is going to give me 18. I need to put 18 more electrons into this structure. So if I put them around the outside atoms, as I'm supposed to do, in pairs, 2, 4, 6, 8, 10, 12, 14, 16, 18, I end up with that. Now I check to make sure my central atom has 8 electrons around it, but it only has 6, 2, 4, 6. Each oxygen has 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So I just need to give my carbon another pair of electrons. So if I move one of these pairs of electrons in, I can make a double bond to one of the oxygens, It now only has 2 lone pairs because I've used one of those lone pairs to make that double bond. And then my other oxygens, it gets a little crowded here, each have 3 lone pairs around them. So that's my final structure for carbonate. Okay, let's look at what we have so far for the CH4 for methane. Right now, I've got 2, 4, 6, 8 electrons in my structure. I need 8 electrons, so I can't put any more in, and I can't take any out. And if I look at my carbon, it has 2, 4, 6, 8 electrons around it. Each hydrogen has 2 electrons. And so that is exactly the structure that we want. We don't have to do anything to make it any better than what it is because everything has a full valence shell. And I don't have to make any double bonds. Okay. Just gonna put a box around all of our final structures. Okay. All right, so if we look at our CCl2F2 structure, we need 32 electrons. We've put in 2, 4, 6, 8. 32 minus 8 gives me 24. So I need 24 more electrons in this structure. So here's my carbon, chlorine, chlorine, fluorine, fluorine. And I'm going to start putting those extra electrons on the outside atoms in pairs. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, done. Okay, I've got all my electrons in there. And now if I look at my carbon, it has 2, 4, 6, 8 around it, so that's good. Each of these chlorines has 2, 4, 6, 8, 2, 4, 6, 8. Each of the fluorines has 2, 4, 6, 8, 2, 4, 6, 8. So everything has a full valence shell. I don't need to do any double bonding. I don't need to move any electrons around, and that's my final structure. Okay, so let's take a look at oxygen. So I need 12 electrons total. I've put 2 in, so I need 10 more electrons. So if I redraw this and start putting my electrons in pairs around the oxygens, I need 10 more. So 2, 4, 6, 8, 10. And now if I look at each of the atoms, I have 2, 4, 6, 8 around this oxygen, but only 2, 4, 6 around this oxygen. So I can remedy that by taking these 2 electrons and moving them in to make a bond, a double bond to the other oxygen, which gives me a double bond. And now I only have 2 lone pairs on that oxygen and 2 on this oxygen because I've used up one of the lone pairs over here to make that double bond. So now 2, 4, 6, 8 around this oxygen, 2, 4, 6, 8 around this oxygen, and so that's my final structure. All right, so if we look at the nitrogen, we've used 2 electrons to make this. Oops, that is not what I meant to do. Let's try that again. Okay, we've used 2 electrons to make this bond. We need 10 total. So we need 8 more electrons. So if I draw that and start putting my pairs of electrons, 2, 4, 6, 8, now I can see that although this nitrogen, 2, 4, 6, 8, has 8 electrons, this nitrogen only has 4. So it needs 4 more electrons. How can I get it 4 more electrons? I can take 2 electrons from the nitrogen that has enough and make a double bond. That'll give it 2 more. It still needs 2 more, so if I take these 2 and move those in as well, then I will have 8 electrons around each nitrogen, and what that ends up being is a triple bond because I had a bond and I made a 1 and another 2 more bonds for a triple bond. That left a lone pair here, and I still have this lone pair there. So my final structure for nitrogen looks like that, and I can check 2, 4, 6, 8 around this nitrogen. Okay, 2, 4, 6, 8 around that nitrogen. So those are my final structures. All right, so I hope that helped. There are problems in the book at the ends of the chapters, but you're going to have to be a little bit careful about which ones you do, because we're not going to talk about resonance and we're not going to talk about expanded octets until next semester in Chem 122. So if you want some practice problems from the end of the chapter, let me take a look at which ones would be good ones for you to do, and I'll give you the numbers for those practice problems. All right, thank you very much for hanging in with me, and I will see you guys on Monday.